Now we want to generate our Gaussian pulses. So I'll plug them into the formula I have this. Since I have 3 Gaussian pulses, so AT1 is equal to exponential minus T over TP1 point square for the second one, and the third one are all the same. So here, because inside the expression, the T is a matrix. So when I raise it to the power of 2, I put a point in the front, right? Next, let's do the graphing. So put this plot. So in the plot, in the input of this plot function, you want to make sure the number of input is an even number because they're going to be pair by pair, x, y, x, y, x, y, right? So I'll put T, ABS AT square, ABS AT square. This ABS stands for the absolute value, 绝对值, absolute value of AT1 point square. So this basically means intensity, right? If you take your electric field, you put absolute square onto it, you get intensity. In the future homework, we always use intensity. So when you're graphing, like if not specified, of course, if you're graphing, just please graph intensity, since that is what your instrument can measure. After you plot, you put the X label and the Y label, and also a legend, since there are 3 different pulses in this case. So also a legend. Now, hit run, and then save it as a file, and see what will happen. 就是 run 它，用那个你的那个 script editor 上面有个绿色的一个播放符号，而且 run 按下去之后，它会叫你先存档。存完档用刚刚讲不能有空格，不能从数字开始，不要把它存在有中文路径，一般存在 C 槽会比较好。然后就 run 它 ，and you get this。我看大家有没有都到这个图。So this is obviously not a Gaussian pulse. It is not. What is a problem? 问你出来哪 ？What's the problem? Right. The resolution is not high enough, right? So you see, we only have 1, 2, 3, 4, 5. 5 points to describe this pulse, and it is far less enough. So we should go back to the parameter setting. So go back to here, the parameter setting in your code. This number is wrong, right? The middle number, the spacing. So should I take this number, decrease it, or should I increase it? 我把它变小变大才对。变小嘛 right? So let's try to use 1e negative 16. 1 times 10 to a negative 16. So it's far smaller. It is like 100 times smaller. We had 5 points. Now we should have 500 points. And then you get this, right? 换数字之后就得到这个 Gaussian pulse. So good. If you want to show others that this pulse is indeed 30 femtosecond, 10 femtosecond, and 3 femtoseconds, you can use the cursor tool. So the cursor tool is on the graphing figure 1 toolbox. So it is here. After you hit it, your cursor will be across, and then you can go onto the curve and then just hit it. You can then move that point by hitting the left or right button on your keyboard, so you can slightly adjust the position of it. So in this case, since I want to specify the full width at half maximum, I simply move left and right so that my y is going to 0.5, right? And I put another one there. If you want to put another one, you should hit in Mac, it is put in option and then you hit it. But for Windows, I'm not sure about the shortcut. But for most cases, you only need 1 point. So you just use a cursor tool, all right? Next up, let's talk about mathematical functions, all right? So in this section, we are going to talk about 3 mathematical functions. We'll talk about derivative, 微分, integration, 积分, and Fourier transform, 复列转换. 3 mathematical functions. Let's start from derivative. Okay, so here's my question. How to numerically perform derivative? We all know how to perform derivative analytically, right? We have power rule, we have product rule, chain rule, quotient rule, all sorts of rules. But if you want to do this numerically, how should you do that? What's the difference between numeric and analytic? For analytic description of this pulse, it is continuous in an analytical sense, right? So every point is continuous. But in a numerical sense, it is not continuous. They are just data points, right? And your program simply put lines in between to connect them. That's why we saw when the resolution is not high enough, we have those kind of linearly, weirdly generated graphs, right? So if I have all these data points, how do I perform derivative? 懂我在讲什么吗？这个图形上有很多个点在上面，这是我们数值方法告诉我们的。在数学，如果你今天是用解析的数学方法的话，那你画出刚刚那个函数，它会知道你的 y 其实是 x 的函数，对不对 ？y 是 x 的函数，它是用什么描述呢？它是用一个 exponential function 来描述。但在 Matlab 里面，它不知道这件事情，它是一个 numerical software， 它只知道我有2个矩阵，一个矩阵叫 t 矩阵，一个矩阵叫 at 矩阵。t 矩阵就存了一大堆数值，它从刚-50 femtosecond 到50 femtosecond linearly distributed。at 矩阵也是存了一大堆数值，那它不知道这些数值的意义是什么。但当你画它的时候，它就把 t 矩阵的第一个数值对上 at 的第一个数值，做成一个坐标放到图上。第二个跟第二个放一个点放到图上，他知道这件事情而已。所以其实你的图并不是一个连续的函数，是一个无数多个点组合成的。OK？ 那我这些点我可以怎么做微分呢 ？Good。AT2， well not AT2。好，这样好了，先写 AT2。AT2 minus AT1。Divide by T2 minus T1, right? This is A prime of T. 是吗？接近，但不是。Because 你要把 AT2 减，不是 AT2 减 AT1， 是 AT 先把这两个相减，然后这两个相减 ，right? You have to do this successively. 就你要把两之间的 y 差异算出来，跟 x 差异算出来，把这两个数据相除 ，right? In Matlab, there is a function called difference, D-I-F-F. 好，我们来看看。帮我在你的程式里面打 %% derivative, okay, %% derivative in the next section. We're going to use only one curve, AT1, like later. So first, type in this. AT difference is equal to D-I-F-F AT1. D-I-F-F AT1. This DIFF is not derivative, it's only the difference. It only takes the y values and find the difference of it, right? Difference matrix of it. So DIFF, AT1, this function simply do this process here. It takes the first 2 points, find the y difference, and store it in the first element of AT difference. It takes the second and the third points, find y difference and put it in the second element of AT difference. 所以它就是把两之间的 y 差放到你那个 AT difference 里面。当然它不知道什么叫 y 啦，它就是把 AT1 这个矩阵的差，两之间的差，前2个差放到第一个数字，第2跟第3个差放到第2个数字，第3跟第4个差放到第3个数字，放到 AT difference 这个矩阵里面。OK？ But this is not derivative. This is only difference. If you want to perform derivative, you should take that value, divide by the resolution of your horizontal axis, right? T2 minus T1. So we'll generate our own resolution, T-res equal to T2 minus T1. So please put this in your code. And then you put AT deriv, which stands for derivative, is equal to AT difference divided by T-res, and then semicolon. So that is indeed derivative. you can know that I didn't put a point in front of divide because AT difference, this is a matrix, but this is a constant. A matrix divided by constant, we don't need a period in front of division. Then let's graph it. Since we've already used figure 1, right? We plotted a figure before this. You should start from putting figure 2 so that your program will know I should put the next figure in figure 2. And then we plot T, AT, underline DERIV, derivative. And you should encounter another error when you run it. Go to your command window and see what happened. When you are plotting, the two inputs must have the same length, right? So what's wrong? 想一下，这个我没有加 t， 然后直接画出来。什么意思啊？你没有加，要加 t， 要加 t， 要加 t， 不加 t 不行，不加 t 你的横轴是1、2、3、4、5、6，这不是我们要的，要加 t。它最后一个点算什么意思？因为你 difference 是拿第一个点跟第二点跟它右边右边那个点减前面。所以你算到最后，你现在 t 加2有10个点。你到第10个点的话，右边没有。Good。它右边没有，所以它会变。Good。众数问题，小学学过吗？众数问题，我有10棵树，有几个间隔？9个间隔。我们今天在算 AT difference 的时候是算间隔，所以这个矩阵的数量会是 AT 的数量减1。OK 吗？假设 AT 有 n 个数值，那因为我是算它的差异，所以它间隔数就 n 减1个差，所以 AT 的长度会少1。那既然 t 跟 AT 少1，我们回想画图的机制是什么？画图的机制就是我 Matlab 只知道有2个矩阵，一个矩阵叫 t 矩阵，一个矩阵叫 AT derivative 矩阵。那我 Matlab 把 t 的第一个数值跟 AT 第一个数值拿出来画个点。第二跟第二个拿出来画个点，但发现最后面少一个点，我画不出来，所以它给你 error， 懂了吗 ？So we do it this way: AT derivative parenthesis n plus 1， 我们增加一个点出去给它就好了。那我让它等于它的 end， 就是我让最后面那个点的数值再重复一次。Well, this is not a very good approximation. It's just like 这是一个没有办法中的办法，有其他更好的方法。我们下课之后如果有兴趣可以讨论一下，怎么样会比较合理。But it will work. So if you add this line, where should you add it? You should add it here. Okay? Like between these two lines. 在 figure 2前面加上那一行，你把它扩增出一个点出去。n plus 1来回忆一下，这个括号代表说我取值嘛，对不对？所以我在这个矩阵的 n plus 1，就是目前还没有值的下一个，就我 end 的下一个那个 entry， 我让它值等于它最后那个 end 这个 entry。OK？ And you should get this after you correct that。你会得到右边这张图 ，the derivative of this function。Is it reasonable? So let's trace this function here. Okay, here I only put AT1, so you won't see this. You will only see the right-hand side graph. This is just for comparison, okay? So see, on the left-hand side, since my curve is approaching a horizontal asymptote, the slope is approaching 0, so you see a value approaching 0 here. My slope keeps increasing and keeps decreasing to 0, so it's increasing and decreasing to 0. And then I have negative slope here, decreasing, increasing, and goes all the way to 0. So that derivative function is quite reasonable.